Hello friends, welcome to this lecture about PySpark on Databricks. In this lecture, we will explore big data analysis using one dataset, that is online retail dataset. Today, we will dive into the core features of PySpark like DataFrames, Spark SQL, and as I said, our dataset is a real-world e-commerce dataset. This dataset captures retail transactions with details like invoice number, product description, and customer IDs. By the end of this lecture, you will be confident analyzing large data sets with PySpark. So let's dive in. In the previous lecture, I showed you how to set up an account on Databricks. So you just go to the community version of Databricks, just to go to compute and create one compute here. Then we need to upload our data set. So let me show you our data set. This is the data set. So we have like 541,000 records. And we have columns like invoice number, stock code, description, quantity, invoice date, unit price, customer ID, and country. So here is the address of the data set. So you can download this CSV file from here. If the file is in Excel format, just you go to Save As, and in here, save it as CSV file. So just we save it as CSV. All right, so in order to upload the CSV file, just go to Catalog here, DBFS, and in here, you can select your file, online retail.csv, and then it will be uploaded. Because already I had it, it is -1. So just copy the path here. Then we need to go to the workspace here and then create a notebook, and just you change it as, for example, to that's correct. So we're gonna work with PySpark. In the previous lecture, I explained about PySpark. PySpark is the Python API for Apache Spark. PySpark is a distributed computing framework that is designed for big data. It excels at processing large data sets across a cluster. PySpark has the ability of supporting structured data analysis, SQL queries, and low-level operations. Databricks enhances Spark with interactive notebooks. Also, it will provide optimized performance and also cloud scalability. That's why it is perfect for data science and analytics. Okay, so let's start coding. On Databricks, the Spark session is pre-configured, so we are ready to go. If you want to verify our Spark session, just you start with Spark, and just you press Shift and Enter. Then your notebook will be automatically attached to this lecture compute that we already generated. So you can see here, a Spark session, Hive, Spark context. So it means everything is already available. So you can see the jobs here. All right, so it means it's fine. So by typing Spark here, we can access the pre-configured Spark session in Databricks. The Spark object is automatically initialized in Databricks notebooks, and it can serve as the entry point for PySpark operation. This confirms our Spark session is active. So let's load our data set and start exploring. In PySpark, we have DataFrame API. The DataFrame API is the primary tool for structured data for PySpark. It is similar to database table or Pandas DataFrames. This DataFrame API is optimized for big data and supports operations like filtering, grouping, joining, and many more. So now we're going to load that data set and we try multiple examples to see how to work with DataFrame. In here, we create a DataFrame. df is equal to spark.read.csv, and we simply pass that address here, dbfs file store online return-1 CSV. Here, our CSV has a header, so header is equal to true. And then we can add infer schema as true, right? So we load the CSV file using the first row as headers and also inferring schema. Okay, that's fine here. It has been uploaded. Now I can display the schema of the data frame, df.print schema. And you can see here, we have invoice number, it's a string, and nullable true, stock code string, description string, quantity integer, invoice date string, unit price double, customer ID integer, and country string. These are the columns and their type. And this nullable, it means in this column, we may have null values. I want to show first 5 rows, df.show, and in here, I will pass 5, truncate as false, right? So here we go. You can see here, this is invoice number, stock price, description, quantity, invoice date, and all you can see here, right? Then I want to count the total rows in this data frame, right? So print here, if total transactions is equal to df.count, right? So we have in total 541,909 transactions in this data frame. So next, we're gonna do some data cleaning and transformation. and we need to import SQL functions for column operation. So for that one, from PySpark dot functions, we're gonna import call to timestamp. We need it to convert the invoice date from string to timestamp, right? So timestamp, then when and lead. Here should be .sql. Correct. Next, we're gonna remove rows with null customer ID if it is there, right? So df clean is equal to df.filter, and here we're gonna filter this column of this one, column of, what is the column here? Customer ID. So we go for this customer ID, right? And if it is null, then we will remove it, right? So in here we check is not null, right? And then we will remove it if it is null. It's correct. We have an invoice date here and it's a string, so we need to change it to timestamp, right? So again, df clean is equal to df underscore clean, the previous one that we have made, and here with column, we check the column, and the column name is invoice date. Invoice date, this one, we're gonna convert it. So this is, we're gonna convert it to timestamp, and then it will be column and invoice date. And then here we can decide the format, right? So month, day, and year in 4 digits, also hour and minutes, right? Some problem here. So this should not be here. It's okay, we have converted. Next, I want to calculate the total price. That will be quantity multiplied unit price, right? So we have here quantity and we have unit price here, right? I want to calculate the total price. So here, df underscore clean is equal to df clean. And in here, again, with column, then the new column will be total price. And this one will be equal to column of quantity multiply column of unit price, right? So let's see our new column. We will just execute this one, df underscore clean, and let's see, we should have a new column, and the new column is unit price and total price. You can see here, total price is here. And if I print the schema of this one, df clean, print schema, then you can see here total price has been added, right? Next, I want to add one binary column for UK transaction, right? If it is UK, it will be 1, otherwise it will be 0, right? So let's see, we have a country here, right? And we want to filter this one, and if it is UK, for example, we will convert it to 1, right? So that one, df underscore clean is equal to df clean with column, and in here we just rename it as is, for example, UK. Then in here, when column of country is equal to United Kingdom, then lead 1, otherwise lead 0. So this function is used to create a new column with literal or constant value for every row in our data frame, right? That is, lit stands for literal. So then again, if I run this one, so you can see here we got is UK 1, right? So country is United Kingdom and it is 1. So in this way, we clean the data by removing nulls, we converted dates, and we add a new column for analysis. So using display, we can see our data much better. And you can see here we have invoice number, stock ID, then we have description, quantity, unit price, customer, country, total price that we have calculated, and is UK. So these are the UK. And you can see here for France, it is 0. Next, I want to do some more filtering and aggregation. In here, I want to filter transactions with total price more than 50 and also quantity more than 10. So high value underscore df is equal to df clean that we did already. And here we use filter function. Then here we get column, and the column is the total price. Total. Then in here we want to check where total price is more than 50. And also we add some other condition. And in here we say column of quantity is greater than 10. So let's see, that's correct. So if I display this one, so you can see here all quantity is more than 10, and also total price is more than 50. Next, I want to aggregate by product and do summing quantity and averaging total price, counting transactions, such kind of operation I want to do, right? So product underscore stats underscore df is equal to df clean. And in here, I use group by function, right? So I want to group by based on stock code and also description. Then in here, aggregate based on what? Based on, let's bring the columns here. So aggregate based on quantity, and I want to calculate sum of quantities, right? So quantity, then here sum, and then I want to go for like total price, and I want to get the average of total price. I want to get average of total price. And next, I want to go and count the invoice number, right? So in here, I want to pass the invoice number, and this time I want to count them, right? Count. Then in here, we need to add the columns, right? So with column, and we rename them. With column renamed, then it will be some quantity. Then in here, then the sum, we rename the columns sum quantity to total underscore quantity. Then we do the same thing here with column rename, then the average total price will be renamed as the, like for example, avg underscore price, so this should be total price, avg dot price. And then again here with column renamed, and then here count invoice number will be renamed to transaction underscore count, right? So we did aggregate by product, summing quantity, and averaging total price, as well as counting transactions. So let's see, it's correct. So now let's display top products by quantity sold. So this one, I'm gonna order by based on the column of total quantity, right? Based on total quantity that we have generated here. And in here, we can decide whether in a descending mode or ascending mode, and then we're gonna display it, right? So here we go. We have average price. This column that we have generated here is this one. Then we have total quantity, this one that we generated here, and also transaction count, right? So in this way, we can show them. So this is the average price, total quantity, and transaction count. This data frame shows high-value transactions and popular products. Next, I want to try creating and joining with a customer data frame. So for that one, I need to create a customer data frame with some unique customer ID and country. So customer df is equal to df clean, and I want to select two attributes here. One is customer ID. I need to run this one again and again because I need these columns. So in here, based on the customer ID and also country, right? So, and I want to be, they should be distinct, right? No repetitive. So I add function of distinct here. So let's see, what do we have here? So we have a new data frame where we have only customer ID and countries, right? Now I want to join transaction with customers based on customer ID, right? So customer underscore transactions underscore df. This is a new df. So I want to join the df clean that I generated already. So I call the join function with which one? With this one, right? With this data frame that I have generated here, and I will pass what? The customer ID, and here, what is the type of the join? Inner join, right? So this is a kind of inner join. So if I display this one, so here we go, customer ID, invoice number, stock, right? Description, quantity, then invoice date, unit price, country, total price is UK, and country. So when you run this code, this inner join, we can see that we have two countries, right? So we have to revise this code. So this one we have to change it, df clean, then customer df, and in here we need to select, and here I for I in customers df, if I is not equal to country, right? Country, then customer ID and join. That column here should add columns. Correct. This one is correct. And we have one country only. Next, we're gonna cache the join data frame for performance. So in here we use customer transaction df dot cache. This cache method persists the data frame in memory across the cluster, and in this way we can have faster access for subsequent operations by avoiding the computation again and again. Next, I want to summarize total spend and purchase count per customer. It means I want to check what is the most total spend based on the total price, and also count the customer IDs to see the total number of transactions, right? So customer underscore summary underscore df is equal to customer transactions, this one, customer transactions, and then I'm gonna group by based on what? Customer ID and country, right? Then I will aggregate them based on what? Based on sum of the total price and count of invoice number. Because sum of total price, it indicates the high purchase, and invoice number, count of invoice number, it means number of transactions, right? So here, total price, then we get sum, and then here for invoice number, we're gonna do count, correct? The result of the sum of total price and count of the invoice number, I'm gonna save them into some columns, and I wanna rename them, right? So with column renamed, then sum of total price, sum of the total price, it will be renamed as total spent, and I will do the same thing here, but this time I wanna change the count invoice number, and this one will be changed to purchase count. I want to display top customer by spending based on their spending, right? So this one, customer summary df, I want to order by based on what? Based on the column of total spend that we generated here. Total spend in a descending mode, and we're gonna display them. That's correct. So here we go. This is the top, right? So this total spend and the number of transactions is 2085, and the rest that you can see here. So in here, we created a customer data frame. We join it with transactions. We identify top spenders. So next, I'm gonna try Spark SQL. Spark lets us query data frame using SQL syntax, and these are great for you because you already know SQL syntax. So here we're gonna register our data frame as table, and we run several SQL tables, right? So for that one, df underscore clean is, so I'm gonna create one temporary view here. So in the PySpark, we have some virtual table or temporary view that we can create them based on a data frame. And in there we use like create or replace temporary view. This allows us to make queries, SQL queries, and also they will be only available within the Spark session. They will not be persisted, and after the session ends, they will disappear. Then create or replace temporary view. This one we use and we rename it as retail, right? So retail, correct. Now I want to do some basic SQL. Basic underscore SQL is equal to spark dot SQL, and then in here 1 2 3, then here 1 2 3, then we can write the SQL code here, right? So select customer ID, description, quantity, and unit price from where? From this table that we have generated here. This is a virtual table, temporary table, and we can make some condition here. For example, where quantity is greater than 20, and also we can sort the result order by based on quantity in a descending mode. That's correct. Now we can display this one. So this one dot display. So here is the result. We say that quantity should be greater than 20, right? So if I say, for example, quantity greater than 18,000, then the result will be only 1 because 1 is more than 80,000. Next, I want to make one query to count invoices and sum revenue by country. For this one, I need to join retails and also I have to join with customer table. So for this one, I need to repeat this one for customers as well. I need to generate another virtual table and name it as customers. All right, now I wanna make query to count invoices and sum revenue by country. So for that one, I need to join retails and customers, and then I will calculate distinct invoices and total revenues. Then I will group by them based on country, right? I can name this query as country summary squared is equal to, again, spark dot sql, then the same here, then like SQL, right? Select from retail, and we rename it as R, right? Then we're gonna join with customers, and we rename it as C. Then between both of them, we have customer ID the same. So R dot customer ID is equal to C dot customer ID, correct? Then in here, I'm gonna select C dot country. Then I wanna count distinct, it means no repetitive. And from the R table, from the retail table, I wanna count the invoice number, right? Then I will rename it as invoice underscore count. I wanna get the total price, right? Round, then in here, sum of R dot quantity multiply R dot units price, and we round it up to 2 decimal places, right? So our retail customer, and in here we need to add on here. Then we're gonna group by them based on the C dot country, and also we're gonna sort them out based on the total revenue, right? Total by total revenue. So for the total revenue, we need to rename this one as total underscore revenue, and then we will bring it here, right, in a descending mode. Let's try. That's correct. Now we're gonna display it. This one dot display. because our data set is very big. That's why it takes time. Here we go. So this is the result. So for each country, you can see United Kingdom, the number of invoices 19,000. This is revenue. So this EIRE, this stands for Ireland, right? Netherlands. So Germany, this one. So you can see here different countries, the invoice count, number of transactions, and total revenue. Next, I'm gonna try SQL for customer purchase patterns. I wanna write a query to analyze customer purchase diversity and average quantity. I need to group by based on customer ID, count the unique products and average quantity. Then I will filter for customer with, for example, more than something, right? So in here, customer underscore pattern underscore SQL is equal to Spark.SQL. Again, we do the same, right? Then in here, select from which table? From retail table. From retail table, then we're gonna select customer ID, then count. And in here, I'm gonna count the distinct stock code, right? Distinct stock code. And I rename it as unique underscore products. Then I'm gonna find the average of quantity, average of item that they purchase as avg underscore quantity. And then in here, I'm gonna group by them, group by based on customer ID, Then I wanna add one condition where, for example, the count of stock code is more than 10, right? So having count, then here distinct stock code is greater than, for example, 10. And then I'm gonna sort them based on the unique product, based on this one in a descending mode, right? That's correct. Now I wanna display this one dot display. So here we go. In this query, what we did, we analyzed customer purchase diversity, and also we get the average quantity that they bought, right? So customer ID, this one, it bought 1,794, and the average quantity was 13 point something. And the last example here, we want to try some SQL for time-based analysis. I want to make a query to sum revenue by year and month. So for that one, I need to extract year and month from invoice date. Then I need to sum the total price and sort by date, right? So time underscore analysis underscore SQL is equal to spark.sql, right? So here select from retail. Then in here, year will be based on the invoice date. Then we rename it as year. Then we get the month again from the invoice date, and we rename it as month. And also we're gonna sum the total price, right? Total price, and we rename it as monthly underscore revenue, right? I want to group by based on year and month, right? So group by based on year of the invoice date and month of invoice date. So this year and month, they will extract the year from these attributes, right? Invoice date, right? And then we will sort them order by based on year and month. That's correct. Then here, let's display this one. So you can see here, it's group by, we use here group by year and month. It means year is in priority, right? So year 2010, 12, so 2011, we have too many, right? So it is 1, 2, 3 in month, right? Then we found the monthly revenue. Okay, that's all for today. So in this lecture, we learned about DataFrames and Spark SQL based on online retail dataset. We learned how to load, clean, transform, query, and analyze big data with PySpark on Databricks. Please try exploring more datasets, and also please feel free to ask me your questions by leaving a comment below this video lecture. Thank you for watching, and see you in the next lecture.